everyone, and welcome. Today, we're diving into something that sounds like science fiction, but is very, very real. Multimodal embeddings. We're talking about the tech that's finally teaching computers to understand our world the way we do, not just through words, but through pictures, videos, and a whole lot more, all at the same time. So, here's what we're going to cover. We'll kick things off with a quick refresher on what embeddings even are. Then, we'll look at the old way of doing things, these separate data universes. After that, the fun part, the revolution that changed everything. We'll see how it created one shared space for all data, check out some mind-blowing applications, and then we'll look to the future. But before all that, let's start with the one big question that gets to the heart of this entire topic. Seriously, think about it. For us, it's a no-brainer, but a computer just sees a string of letters on one hand and a grid of pixels on the other. They're completely different things. So how do you build a bridge between those two worlds? The answer to that? Well, that's the key to everything. Okay, so to get to that answer, we have to start with the basics. Before we can get into the multimodal part, we need to be crystal clear on what an embedding is. So, what is an embedding? You can think of it as a translator. But instead of translating from English to Spanish, it translates meaning into the language of math. An AI model takes any piece of content, like a sentence, and converts its meaning into a long list of numbers. And that special list of numbers? That's called a vector. The process itself is actually pretty simple on the surface. You give it some content, the AI model does its magic, and boom, out pops a vector. It's that list of numbers that holds the secret sauce, the actual representation of the original idea. So, why on earth would we do this? Why turn everything into a bunch of numbers? Well, it's because computers are amazing at one thing: math. Once everything is a vector, you can do really cool stuff, like measure the mathematical distance between them. This tells you how similar their meanings are. It's literally how an AI figures out that the word king is super close to queen, but really far away from apple. Now, that whole process works great for text, but for the longest time we had a massive problem. Different kinds of data, like text and images, were basically living in totally separate digital universes. They just couldn't talk to each other. And this was the fundamental issue. You had AI models that got really good at making vectors for text, creating this text space. At the same time, you had totally different models creating vectors for images in their own little image space. A vector from one universe meant absolutely nothing in the other. They were speaking completely different languages. There was no way to compare. But then, somebody had a revolutionary idea. A breakthrough that basically ripped down the walls between those universes and ushered in the modern age of AI that we're seeing today. And this was it, the big what if. What if, instead of having all these separate spaces, we could train one single giant AI model to map all these different types of media into one shared universe, a place where every piece of data, no matter what it is, has a common frame of reference. And that's exactly what they did. All of a sudden, we had these incredible new models that could understand text, images, even clips of video, all at the same time, all within the same system. The result of this revolution is honestly profound. It gave us a unified world for our data. It created a place where an idea, whether you write it down or take a picture of it, could finally be understood in the same way. You can think of it like this. We finally created a unified language for data. It's not about a world of text and a world of images anymore. It's just one single world of concepts all represented by numbers. Which brings us right back to our cat question from the beginning. The huge insight here is that in this new shared space, the vector for the text, a picture of a cat, is going to be incredibly close to the vector for an actual photo of a cat. The AI now gets it. It understands that they represent the same core idea, just in different formats.
All right, so this is all super cool in theory, right? But what's the so what? Where does this technology actually show up and make a difference? Let's look at some real-world applications that are only possible because of this breakthrough.
Okay, take analyzing a PDF. The old way, which we often call traditional RAG, would just pull out the text and literally throw away all the pictures, charts, and diagrams. It was only getting part of the story. But now, with multimodal RAG, the system can understand the text and turn those charts and diagrams into vectors, giving it a complete, holistic understanding of the whole document. And this didn't just happen overnight. This has been building for a while. OpenAI's CLIP model was a huge pioneer here. It was the engine behind those early text-to-image models like DALL-E. Then Google came along and pushed the idea even further with their models. And that's what's brought us to today, where this tech is powering really advanced stuff like that multimodal RAG we just talked about.
So, if that's where we are now, what's next on the horizon? Where is all of this incredible technology headed? Well, the next big frontier is almost certainly going to be audio. Just imagine this for a second. An AI that hears the sound of a cat meowing and understands that it's related to the word cat and a photo of a cat. It can place the vectors for the sound, the word, and the image all in the exact same neighborhood inside that shared space.
And that really leaves us with one final, pretty mind-bending question. If an AI can truly understand the concept of a cat, whether it sees it, reads about it, or even hears it, what are the limits? What else can it understand about our world? That's the future that multimodal embeddings are building right now. Thanks so much for joining me for this explainer.